Okay. Hello, everyone. Welcome to another SparkyNinja podcast. It's Dave and Dave here again. We're going to bring some more discussions about training, industry, and other things. What we're going to kick off today with first, Dave? What do you want to talk about first?
Well, I think how our week's been so far would be a nice
How the week's
start for us.
I've got 2396 week this week, so I've got some guys doing some real heavy practicing and crunching out all the calculations, and they've probably overdone it a little bit. They're a little bit, the head's hurting a little bit. But it is what it is with the 2396. They've kind of got to just push on through. Exams coming up this week. Get that out of the way. The weather's got warmer as well, which is nice. But yeah, exam week for me. What about yourself?
Yeah, doing some prior kind of site visits to our next oncoming jobs, walk around the site, meet the clients, inductions, a bit of the routes, a bit of how the design's coming on. Somebody else is designing this one, and it's just a sort of pre-check, not like go over the design completely, but anywhere I can assist or help, or I notice something that I might want to.
So you kind of like collecting the designer's pre-data, maybe, getting some of the stuff that they will need to know to design, or is the designer going there as well?
Designer's been there. I haven't met the designer this time on site. I've got all the documents and stuff to go over. I meet a site PM there. We go over, have a walk, discuss the job, see if we can put any input into how it's going to go in. It's quite some big cables, some 400mm 4 cores coming from a transformer, 750 kVA, about 1000 amps a phase, and that's going probably 30 meters into a LV panel. So there's quite a considerable amount of bends, and
that's quite a bend. That's
yeah, and then it gets into the consideration.
Those bends take up a lot of space.
Exactly, and there's already ducts in there. There's plant room. There's already ventilation in the way. There's challenges that we have to get around to kind of make it work. Get rid of the ducting whilst we pull it in. Rather interesting job. Looking at the weights of these cables.
They're weighty.
They're about 20 kg per meter.
Yeah.
So I think the ladder's 750, so we got a safe working load if we put the fixings from the roof down at no more than 2 meters. We can get a safe working load of about 250 kg per meter. So hopefully by the time I calculate, and I'm pretty sure it's been calculated already, but calculate out the number of conductors, I think it's 6. So it's definitely under 250.
For that kind of weight, though, do you get like a structural engineer to back up what you do, or do you get some data on tolerances? How do you know that you?
Yeah, it's backed up by a design engineer anyway. It's just more for my kind of understanding. Then, like with the fault current levels, the special type of trefoil cleats that you've got to have, and the spacings. You got to take all that into consideration, and then we're not doing singles because you have to clock the singles around to put them all on fairly. So yeah, it's an interesting, challenging job. We're changing some boards, which is nice. Upgrading, so a bit of testing on the existing installation to be done, and then go on. Got really good O&M, really good maintenance on it.
Excellent. I remember, this is going back about, I don't know, probably the best part of 15 years or so now, but I was doing work at a boarding school, and there was a feed to a whole new science block and art block, and the cable pull was quite a thing. We had, we were on the fire crew at the time, so we got the fire pump to come on and help throw the cable through, because it was quite a pull. But when we got into the little switch room, once you got the core hole through, you got that big cable in there, you realised that the bend of that cable took up the entire room. You had to go down, then along, then come up, and then come over. When you have these large cables, these bends do have to have a serious amount of consideration, don't they? You have to really design for them.
Yeah, and it comes in like 5228.3, which you've got kind of like you can't exceed the bending radius. You might diminish its life. You might short circuit. You don't want ripples and tears in the conductor. It can be quite a mathematical thing. I think it's a lot we don't really do. I think the on-site guide's got a bit in Appendix D where you got diameter times the usually a manufacturer factor, but I think they give like like a 6 for an armored thermosetting cable.
Yeah.
In the on-site guide, and then what I tend to do is draw it out and make a big wooden circle.
I see, like a template.
I'll take that with me.
Yeah.
And a template, so I can kind of gauge where I'm going with it.
I remember once.
If you just wing it in, it can get a bit.
Yeah, I remember once I was working doing some 7909 testing, and I was at this feeder pillar box, which was a broadcast power box. We had a load board that fed 2 other boards, which had a load of 16 amp and 32 amp 60309s off of them. And I could just tell by how tight the bending radius was in these 2 armors from the load setter to these 2 boards that there was a lot of tension on there. But you could really tell when you tried to undo the cover to actually inspect inside, where you could feel that there was strain on the screws from the stress in the actual box trying to twist. And so I took the relief off of the bend, we undid them, and then as we took it back, the actual rivets in the box had popped, and it was just the board holding the enclosure square, just because that they actually had this excessively tight bending radius, just to make it obviously fit, adjacent to it. And the only fix in it, these two cables were crossing over each other, feeding one board and the other. The only fixing they installed was one nylon cable tie at the point where the 2 cables crossed over to stop any left or right movement. There was nothing to actually support the weight of the cable itself. It was absolutely shocking. But it was only when I actually went there and actually could feel the tension in the board that I kind of sussed there was a big issue. And you're right, I think cable radius is something that we don't really take much attention to. All the cable manufacturers provide the data, but for us to practically look at the data and use it, I think that's something that we can improve on. And I think I've seen many examples, especially with things like smaller form MIs, SYs, and so forth, where they're just literally just really tightening them around spaces.
Yeah, it's quite interesting because it does apply to containments and wiring systems as well as just an SWA cable. So you kind of got to consider it with everything. It's interesting. I do find the weight kind of aspect of it interesting too. When you start looking at the cables onto ladders and stuff, and you think, well, like 82 kg per meter. That sounds like quite a bit.
It's a lot of force as well. And then there's the fixings themselves as well. That's a whole new area that you need to explore as well, because you just can't put your red plugs and 1.5 in, when you're talking about this magnitude of weight and stress. So you need your concrete screws or similar. There's one of the stands that we have on fixings and things, and it's another area that we probably should actually look into and tear into. I think that's one of the areas that Paul's actually pretty firm with when he does his work on his route, is the fixings and making sure all the contractors have the right specification for the fixings to use as an asset. As an asset manager, that's kind of one of his core things to work on. What else? Anything else this week?
Basically, just go to sites again, reviewing, having a look, site meetings, usual stuff.
Meetings. Do you do much tool stuff?
Yeah, just meeting. Try not to.
You try not to.
Yeah, I do get on the tools. I do get on the tools every now and again, and you do tend to miss it when you get that kind of job.
I bought this at Alex. I bought my solar crimping kit because my one was knackered, so I did a little bit of looking and I bought this. Ridiculous cost for what it is, but I've got to tweak my solar rig because I bought for my solar rig at the centre. I got this guy to get me the bits. I said I just need an inverter. A string inverter is all I need, because with the Sitting Guild courses, you can't have one assessment rig that does basically prosumerism. We can't have a rig that combines other MCS things. It's got to be a solar and it's got to be a battery. We can't have a crossover system, not for the assessment anyway. So I ordered this stuff, and the guy sent me a hybrid inverter, and I was assured the hybrid inverter would work on DC solar only. You'd have an option, but you still need to have the batteries connected to it, because when you start it up, it does that check that the batteries are there. So I've got this hybrid inverter on my solar rig, and I have to put the batteries into it for it to actually turn on when I just want it connected as a string. So I've got to go back tomorrow when the guys are getting ready for their exams and stuff, and I've got to cut open this little solar rig, and I've got to swap the inverters around. It's only a epoxy little system anyway, because it's only got like 4 panels, but So I bought that, and that weren't cheap, and I got a discount, I think. At least I was told I got a discount. I also got the clamp meter that goes with it. You know, the solar clamp meter as well. So I got some things to play with, got some toys. That's why I chose not to go to CEF Live, which I saw online and it looked like it was very impressive. You've been to one before, CEF Live?
I've never actually been to a CEF.
You've never been to one?
To be honest, I've been to LX.
Yeah,
I always miss it. I don't know.
I think it's a 2 yearly thing. It's a 2 yearly thing, and it's quite it's quite big. I was going to go, but when I went to Alex Harrogate, I got completely my wallet it burnt out. I walked past QTech. I bought a little EV adapter as well from there. So I'm going to go to the installer show because I'm interested in the CPD, heat pumps and stuff. I'm interested in the crossing over here, the demands on systems and some of the paperwork trails that's needed there. So I'm going to go down to the installer show, which I think is the week after next, I hope, because I have a 2391 next week. But I think that's probably me CPD'd and exhibitioned out for the year, or financially it is, that's for sure. So what's happening in the industry? Well, news this week. So we have had an update on the neutral current diversion industry research, which is great. This is something obviously we've covered diverted neutral current on the E5 podcast. We've covered them on John's covered them on his channel. I've covered them on mine a bit. I've done events demonstrating neutral current diversion. I went to Northern Ireland. We've been doing our bit to try and raise awareness of this, and we're still trying to learn more about this. And industry, the trade organisations, NIC, ECA, Electrical Safety First, Select, and NAPIT have been sending out a QR code, which I shared, to try and get us to feed information in about our awareness of this. And there's been an update, just to kind of look at where things are. So I'll just read some random bits from this. So yeah, a little bit about the whole point of this, what they did last year. So the most common earthing systems reported were TNCS, that was reported to being approximately 76% of the systems, TNS 22%, and TT being 2% of the reported systems. That's fairly understandable. It's widely accepted that PME is used for new installations. There's a little bit of talk about the whole requirements here. But the interesting stuff gets further down this report that they've published. What methods were used to determine neutral current diversion? So the clamp meter being checked before and after isolation appears to be the one that's most used. That makes sense because it's the one that obviously doesn't involve any direct live work. It's non-invasive. You can just check the amps, shut the system down and see if there's any power still there. Most people are finding that quite successful. 57% of those responded utilised the clamp meter as a method to determine it. Other methods, though, a contact voltage indicator was used, so the contact, not the non-contact. When we covered phenolic degradation, we showed the contact voltage indicator that we have, the QTech one. I've left mine at the centre, I haven't got to show the camera. But fundamentally, in Openpen conditions, the external parts will rise to mains voltage in neutral current diversion, so a contact voltage detector is one of the common ways it's being done. But other methods also have been explored, such as the presence of arcing being seen. Gas fitters, plumbers are still seeing the current just by disconnection and reconnection of pipes. So I think this is promising. It's been a promising response. With regards to what's been measured, it says in 67% of cases, respondents have found an unexpected voltage that first highlighted the neutral current diversion. So it's a foreign voltage that's been there that's raised their suspicion. And that makes sense. If you've got a neutral that's fluffing around, it makes sense your voltages are going to be a little bit strange. The average current measured through the earthing conductor and or extraneous conducting parts was 12 amp, but the highest one recorded also was 67 amp. That makes sense to me. The highest that we saw when we did some work was logging about 40 something amp. So it seems highly plausible that that's definitely an accurate number. So they're updating the article and saying it's not just a concern to electricians. And I think the conclusion is they just want us to carry on raising awareness and feeding it in, I believe. How do I report it? So they have this online form. So if you have the occurrence of neutral current diversion, you go to their site and then you give them information such as how you detected it, what earthing system is. And I guess what's happening is the industry just wants input of information here. just to kind of then determine what reaction there needs to be and to what significance and severity that needs to take. From the training section, I've seen when we had the new apprenticeships launched, there was a mention in the health and safety unit about awareness of neutral current diversion. I've seen nothing from a production perspective of material on that. I provided my own, but I've not seen any other examples of that. So that might be something that it's a good idea for someone to produce. Otherwise, yeah, it's just an update really. We don't really know the significance and severity of it until we've had a bit of time. But it's definitely, I think, on the up. I don't think we're surprised by that news. What do you think?
Yeah, I think it's definitely on the up, and it's something that's been around for quite a while now. It's getting more awareness, which can only be good. It's amazing how it can also be from a neighbouring installation and not just your own installation. So you could be experiencing currents from your next door neighbour or the network somewhere else.
Yeah, and what's been nice is, I mean, I've heard like John, and I've seen mentions of it here, is even though if you measure current and there's nothing there, and then you begin the work, it could be that, as you say, the neighbour isn't at home or there's very little amount of current, yet during your work they turn up and they turn on the loads, which generates that larger a level of current, which is, you know, a big concern. There is a bit of connection to this with some other information that I got, which I looked for before we started recording. I couldn't find where I downloaded the blooming thing, but there is feedback through, obviously, Paul having attended the Earthing conference and talking with the ENA about a latest update on theirs. They have updated a consideration of 10 amps being an acceptable value of what they call net current, which is a combination of, you know, net, which is collective current through the pen connection through TNCS systems, which they could also translate to be some form of neutral current diversion or net current. But they think that 10 amp is acceptable as a norm. So what that means is if you're measuring for neutral current diversion and you have anything 10 amps or less, they may just go, yeah, we expect that as net current. So they may have to, if that gets concrete, the IET may then have to go, okay, if we identify anywhere between 0 to 10 and it's acceptable as net, if they're not going to listen to us if we report it, we may have to then go to the next step, which is to look for the presence of a voltage, which I did see mentioned in the PE article with a, you know, real hazardous mention that it is a live activity, but that is only the real way to truly determine at that point if it is an open pen, is to disconnect the earthy conductor from the exchange conductor parts bonding to see if there's a voltage between those two systems. I remember that could be 400 volts, so, you know, that needs to be very delicately approached, because it looks like the suppliers may accept anything up to 10 amp as net current. So I don't know where we're going to go in the long term. I think 10 amp is obviously, even if it is potentially neutral current diversion, 10 amps is just way too much. If there's a voltage behind it when we break an earthing system, we need to look further and look for the voltage, and that might be that we have to revise the guidance and step that up a little bit if ENA is going to push 10 amp as a norm out there, but we'll have to see. But that was announced earlier this week. Another thing that I have got is an update for anyone who's been on an EV course with me, or just hear me talk about Openpen, you, right? Is we've had this wonderful storyline of how Openpen protection works, pen protection, and is it okay just to buy an EV charger that has pen protection written on the thing and put it in, set and forget, because, you know, it's just a radial circuit, as some people will say. There has been this long story about, obviously, the challenges of the development of pen protection. The IET in 7671 saying that we need to achieve, you know, protection that identifies as low as 207, as up as 253, and then we also need something that will see if the voltage between reference of earth and 0 moves over 70 volts for a period of longer than 4, no longer than 5 seconds. It has to turn off and all this stuff, and we've seen companies come up with these ideas and methods to kind of model this, but the reg says you can put this protection into your charger, which creates the problem because 61851 doesn't let you switch the protective conductor off in your charger, 8.4 of 61851-1, and that has meant that very few manufacturers have actually mentioned this in their literature. We comply fully with 61851, except for 8.4 because we look at 7671 instead, which has got nothing to do with product standards. This has been an ongoing problem, and the wine regulations in 722 has had this ongoing issue with regulations. The conclusion being that if you use Openpen protection instead of the TT adjustment, you have to get the declaration of conformity. You have to then get that from the manufacturer and identify the declaration of conformity includes voltage sensing technology as a reference in the IT code of practice. If you do that and you attach that to your initial verification, your installation is no longer a departure. If you don't do that, it's a departure and is potentially codable in the future. So if you've not been doing that for your EV installations with Openpen protection built into it, you've not been installing these properly to 7671. Read the words in the book. That's all I'll say. And so the problem has been that we've not been getting any regular updates, and so it's deciding where to go. And then we had in 2023, we had UK Power Networks identify this issue and say you cannot have an Openpen protective device installed in a lighting column or anything because we don't identify this protection device because it's not got a product standard. And that's where MAT-E or MAT-A got involved with obviously pushing and verifying their device complies with the EREC requirements. So they got acknowledged by UK Power Networks. And then the IET published IET 01, which is the Openpen Protective Device Standard or something. I've got it. I've read it. I just need to read it many more times. It's a bit like a scrapbook of protection technologies. Where are we now then? So we're now at a point where it's been relaunched or updated. So UK Power Networks is one of the first to do this, and it happened just week before last. And they're basically saying that the IET01 device is recognised by them. So if you've got any on-street charging, anything that's going to go in the UK Power Networks sector, you've got to make sure your charger has a Openpen device that's manufactured within the guidance of IET01 or is in some way IET01 compliant. This is something that they've not done at all. So it's an interesting time. And I spoke even with MAT-E guys today, kind of figuring out where their position is on this. Because the expectation here is now that we've looked at the requirements of EREC G12 and they've been done, and we've got this new update from UK Power Networks, that everybody will have to select an IET01 compliant Openpen installed charger if they want to not use TT systems. Most chargers won't have that. And we're trying to look at what Beamer are going to do. We don't even think, because Beamer wants to do what's good for its members, which are manufacturers. So we have a feeling they may try as much as they can to kind of ignore IET01. But what UK Power Networks have done is said, oh, we want that. And they said IET01, we need that. So this is a really interesting time to see what this reaction is going to be. Because it might be that an awful lot of this gets re-stamped, remarked, or they get them tested and they are IET01 and you have to update your paperwork. But an awful lot of stuff's being installed, but we're still now getting updates in what is acceptable to install. And it's one of those things that we're still, even today, we're getting more information and we're waiting for new things to change. So that's fun. It's exciting because it means I've got to update material again, which means I've got to go back to these things and tweak things and stuff. But it means that at least we get some, not conclusion, but we've got some direction. We've got some direction for me to divert people's attention to. So that came out. I just got a lot, I've got to catch up with myself and get all this 2396 out of the way so I can get all these slides and all these things updated. Big fly in here. But
does that mean another course?
Does it mean another course? No, it's
Thank God.
no. I mean, the training industry has made an absolute joke of renewables. I run a training company. I tried as long as I can to hold off solar and battery. I still am holding off, to be fair, because we're learning new ways to regulate. I had a chat with a gentleman from the IET, a very, very knowledgeable chap, John, and a few other lads there about inverters. And we just laughed and said, why would we put inverters in lofts? These devices are manufactured with sensitive electronics inside them, and they're supposed to be in dust-free environments. And I've got an inverter in my centre now. I just looked at it today. It says IP65. So it's not supposed to be in a dusty environment. So these little things where at some point we're going to have to then change our behaviours and the way we do stuff. We had this problem with batteries. You know, quite aggressively, we were then advised under the pass to take them out of the lofts. I was one of those guys saying, just never put them in lofts from the beginning. I have the same opinion with inverters a little bit. There should be a real limitation on what we put in that loft, because it's a very harsh environment for sensitive electronics. Unless we have them enclosed in some way, which electronics don't like, especially equipment that heats up. We've got lots to develop still. We still have to develop Openpen. Openpen gets very warm. Pen protection gets very warm. So there's all these things that we need to get developed. And that's the problem we have in the training space, is we just go, oh, can I deliver this course now? Right, I'll send it to as many people as I can. And who cares if in 3 months the industry changes, as long as we made our money. And that's, you know, it's one of the things that I don't get involved with. But the industry, the EV courses, they've all had issues. They still have issues now. The large scale course has an issue, doesn't quite reach the large scale sector. My course has been adjusted, and I fed this back to Sitting Guilds and the IET. Mentioned it on previous podcasts, I think, that the issue they have with the IET is the ERA calculations. They can't print them because they're obviously private property, so they can't guide the industry in the way the industry's gone, which is becoming a problem. Not for me, I can just download them and I can deliver them. But the IT, you know, they can't just download tables from a private experimental study that now this industry is using. They just can't replicate them in guidance documents because they don't own them, or they don't have rights to them, which puts the training at risk, or at least the guidance electricians receive at risk. So yeah, it's a fun time because it's a bloody complicated time.
Should we go for books?
Books. Let me have a look. What else do I want to cover? Things I like. Oh, there's one other thing I wanted to discuss, but let's do a book. Let's cover one of your books or my books. Whose book? Who's going to throw a book in the air?
I was going to cover some CPD as well, but
your CPD.
This is the, well, you could call this my CPD and my sort of book. This is the commentary of the 15th edition by BD Jenkins. And as from our last podcast, this has actually got the K-factor correction calculations within it.
Oh, from 4545? No, 7454. That's the one. So
yeah, that's
so
the
they're
one.
in there, are they?
Has that in there?
Why are they not in our
Funny enough, it also,
commentary?
well, yeah, well, the 18th I don't think has one at the moment.
No, it doesn't actually, does it?
Apart from your stuff online, of course.
So Jenkins, he's the guy that did the touch voltage book, yeah. Yeah,
he was quite big back in the 80s.
Yeah, no, any book, if you go on to worldofbooks.com and you can find a book with his name on it, I just think you should buy it. Although check you haven't already got it. He's done a few.
It's a different format of math and regulation. It's quite heavy.
Yeah.
There's lots of
it's more engineer written, isn't it? You know,
it's very engineer written.
Yeah, but I love that stuff.
I do like the adiabatic equation in here because he cancels out the square root. So he basically doesn't have the traditional S equals square root I squared times T divided by K. He actually cancels the squares out and has the current unsquared times square root time divided by the K. I think that's just so much an easier way to do it.
Yeah. Okay.
Yeah.
No, I must have that book or a book like that. I've got a lot of my books are at the centre at the moment, but I must have one of those because I've got a few of Jenkins' books and Coates, Mark Coates, Jenkins.
Yeah, Coates are never good.
Yeah, those are good ones. All right, I have been reading, and I've had this a while, but I'm reading it again. It's actually not written by anyone electrical. It's someone from the specific sector, but this is Heat Pumps for the Home. And the reason I've been reading this is, I'm going to go to the installer show, and I just want to kind of absorb as much more CPD as I can about heat pumps. I got pretty much the cut of how it's all working and stuff, and the impact on electrical systems, how the whole thing is working. But I just want to kind of really binge on some CPD with that. But what I like about this is it also kind of lit the spark I have in my thermography head. Because obviously my thermographer training covers thermodynamics, it covers heat transfer, heat behaviour, and one of the things this has is a really nice introduction to the heat, to how heat behaves. you know, and how you then utilize the way heat behaves in a way of a heat pump, where you know, and it also applies to air source pumps, where you can just utilize the heat that's inside and it's very cold. You can still get the heat out of there, and you can get it to react with a different chemical to create a boiling point. So I found this to be a really good, interesting read, actually. And as it's kind of written by, you know, just a random chap, it's got some fairly interesting images and diagrams, but the way it's written, the wording, the language, I found it very easy to read. And I think any electrician that's got some slight interest in heating systems, or, you know, heat pump systems, just from the concept of, you know, how heat pumps will actually kind of work and stuff, it's worth just exploring for the fun of it, I think. And this other book I have I have this other book on my desk. This is this one. Bit pricey. The Electrician's Guide to Domestic Electrical Energy Storage Systems. They call it the on-site guide for energy storage systems, but I thought the on-site guide was about 25 quid. This was double that. But they are writing a similar book for solar, as far as I was told. So the IET is getting in that guidebook, smaller format thing. So the question really is, do you want the code of practice or this or both? The code of practice you need if you do a course, because your assessments are all based on that. But this is a lot more user friendly, and there is more in it from the, you know, from the on the tools and in the actual real event perspective. Whilst the actual codes are a little bit, you know, a little bit over technical. This is a little bit easier to read and digest, in my opinion. I've had a good read of it a couple of times. There's some good contributors on this as well. So yeah, I've enjoyed reading that. Have I changed my energy storage course based on that material? There might be a couple of things I've tweaked, but most of the changes I've made have just been stuff I've found by my own CPD. But yeah, no, that's a pretty good book. All right, now there's one thing I wanted to discuss, and that is a little frustration I've had, because I've had so many people message me and ask me this question, because there's people who give one opinion, there's people who give another opinion, and I don't want to upset people I like, because I like people, you know, I like people. I can't help but offer my opinion sometimes, and probably not make everybody happy. And I get asked a lot of things, and I've got to be honest. And the thing I want to discuss now is surge protection, and two parts with it, which I have been talking about today online, is, do you have to test surge protection? Can you test surge protection devices with a tester? And also, do you or do you not need overcurrent protection for surge protection? So, two little things that have been annoying me. So the first one is testing. What's your opinion on testing of a surge protected device?
Well, it can be done. I've seen testers that claim and state that they do test them. There is also debates whether it sort of like takes a little life off the surge protected device every time you test them. So could that be a potential issue?
It comes back to this point of, you know, people. It's kind of like it's like Jeff Goldblum in Jurassic Park when he played Ian Malcolm, saying you put all this effort in to figure out if you could, but you didn't ask yourself if you should. And the question is, yes, maybe we can test an SPD, but should we? And this has kind of caught my attention, because we can use an insulation test to drive a voltage, to drive a surge, to close, to then operate it as a device. But inherently, we understand that that's not the actual condition it's going to operate in. It's not going to operate when it's being pushed by a insulation test or a tester that's trying to simulate that. It needs to have very specific transient energy for it to operate, or it's supposed to operate in that characteristic. So whilst our tester may operate the device, that doesn't represent how it will operate in the real transient event. So is it really a test, and does it really verify anything? And that's what's been kind of, you know, annoying me a little bit to kind of figure out, because I get asked that question. And in the testing course, I love QTech, I love these testers. They have the SPD setting, and I kind of go, you don't need that really. And so I'm a big fan of Q-Tech, and I saw an article by them about why you should test SPDs, and I was like, it sells your tester, but I don't know. So I've asked some surge companies. I asked surge companies, and all of the surge companies I'd asked, which was about half a dozen, all but one said you don't need to do it. And the one that said you don't need, the one that said you should do it or you could do it, I won't say which company he was from because he was quite sensitive to ID. He was actually in our Discord for a period of time when we had these discussions a year or so ago. We had these discussions, and he said, "Yeah, I know it's a useful thing you can do," but everybody else was adamant, no. So it was definitely the consensus was no, you shouldn't. And I spoke to a few of them, and Dane in particular I speak to a lot because they're quite quick to reply. The guys at Dane are fantastic, and they put up a thing on LinkedIn today. I don't know if it's a direct response to the article I shared, but they put this up saying about testing, and it says there's no regulatory requirement to test SPDs. In fact, it specifically states in BSCN 62305-4 edition 3. I don't know if we covered edition 3 on the E5 podcast, but we did cover 62305 with Dane. It states that SPDs should only be tested if there is no means of status indication. Now that's true. There was another person who said, well, our SPD doesn't have a status indication. But that was not in the UK. It's believed to be more of a UK issue. But there are methods to verify when you don't have status indication. But so it says it's not necessary. Given that all SPDs in the UK have some form of status indication, visual audio, remote monitoring, there should be no reason for electrical testing. Now, those were the words by Sean at Dane earlier on, and there was an article that matched this, kind of suggesting that 62305 only requires a visual inspection every 12 months. Multifunction testers are incapable of testing the dynamic function of an SPD, especially a Type 1 device. Typically, MFTs only check nominal voltage, which isn't sufficient to confirm whether your SPD is operating correctly. So, the story that I wanted to address here is we always need to check very closely with the specific manufacturer. Manufacturers of testers want to sell testers. Manufacturers of SPDs want to sell SPDs. But when we're looking at what's best for what we want to protect, we should make sure we are very clear on our advice and where we get information from. Carrying on this Surge article I wanted to discuss is another one, which was, do you need overcurrent protection before your Surge protection? What do you think?
There's been this debate before where some manufacturers state that they basically have an inline fuse that doesn't basically require you to have overcurrent protection.
Right, and that's exactly the point, isn't it, mate? You need to check the manufacturer specifically. Now, the majority of manufacturers of SPDs in this country, most of them will import them from China, have them branded, because they won't be specialists in Surge. Some are. Some do a bit of manufacturing in Europe. Dane obviously are a manufacturer in I think they're mostly in Germany. But the majority of others, and there's nothing wrong with their SPDs, let's address that, but they buy them in from China and they'll get them branded and stuff. They're fine, they're safe, but where they're made there, the method is that they're not providing any internal overcurrent tolerance, so those will require an MCB to protect them. And that's the manufacturing process. But some manufacturers, they manufacture them with built-in protection or some form of tolerance against overcurrent within that boundary. Okay, Dane is an example of this. This is why I go to Dane about this. Not all of their SPDs, so some of their SPDs you do need overcurrent protection for. So again, you've got to look at the manufacturer. Okay, and again, there was an article about this, but again, I mentioned this to a person. He sent me a YouTube video from Navitas, where the guy there said, you must, unless there's another thing you must. And I was like, okay, let's just chill. You need to look at every individual manufacturer. If Navitas say you should, then with Navitas SPDs, you should. If Surge say you should, with Surge, then you should. If Dane say with these ones you don't, then you don't. And it's as simple as that. And I did actually, I messaged someone just to confirm this earlier on. if he could provide further guidance on that. And they said the advice, this is from Dane about Overcurren, the device never changes on this subject. All SPDs have a current withstand capability purely by way of manufacturer. If the supply current is equal to or less than the SPD rating, then no additional overcurrent protection is required. Adding unwanted overcurrent protection simply adds additional cable length to the SPD, which, if you refer to 5347671, can then impact on the SPD's operation, specifically the voltage protection level, or the UP, on the device, which is the main thing we need to achieve. So again, it's I can imagine the majority of Sparkies and stuff just don't buy Dane or whatever, or I'm trying to think, there is one other manufacturer, I've forgotten their name, who you don't need overcurrent protection for. Oh, I've forgotten their name. And obviously we're probably just using the others that do, and that's fine. But what we can't do is parade around saying you must. What you must do is always, and we know the reg says this, always comply with the manufacturer's information. So that's the question that you ask the manufacturer. You don't ask a Facebook or whatever unless you say, hey, I have this product, do I need overcurrent protection? And then someone can look for them with the manufacturer. So always the manufacturer you've got to get that from. And let's remember that these standards for protective devices, surge protection devices, all these devices, the product standards are goal setting. They say your device must achieve this, and there'll be some characteristics that they must stay within, such as altitude, such as thermal behaviors, such as EM efficiencies and things like that, EMI. But the way they perform in the middle can differ as long as they achieve the same goal. And so that's why we have devices that are very different. SPDs are different to other SPDs, overcurrent devices, RCDs, AFDDs. That's why things cost different amounts of money, and that's why things perform differently under certain characteristics. That's just the way it is. They're all manufactured through a different level. If you get involved in complex design, as you probably do, you start to look more closely at the manufacturers, at their spectrum of devices. And you start to realize how different they are to each other. Things like let-through energy. You're working on let-through energy. You go to one manufacturer, here's loads of data. You go to another manufacturer, and they'll go, let me get back to you, and they may not even have your information for you. So they're all very different, and it's it's one of those things you get with more experience. You get to realize how that is. Do you have anything to add on to that?
Yeah, I was just quite curious of QTech tester and this SPD setting. It's so basically it's IR that's insulation resistance that's doing the test. So when you put it to SPD, what are you actually doing?
Yeah, no, I don't have it on me. I have one. I love it. It's a great tester. It's in the center. I'm sure there's something else that they have done other than just an IR test. Maybe a pulse, maybe a high voltage strike or something. There must be. But from what I've heard when I've spoken to surge manufacturers about it, it isn't the same as a legitimate SPD testing thing, which costs thousands of pounds to simulate the transient, which I can kind of understand.
A lot goes on in it.
Yeah. So
an MFT does a lot of stuff, and it's just not as good as a standalone unit.
Well, I mean, you'll know for that. I mean, look at the low resistance ohm meter that you were using. Fundamentally, there are limitations to MFTs, which is why sometimes we have to go a little bit bigger and spend a little bit more money for more accuracy or for more performance. You had that experience when you were doing impedance tests on, was it buzz bars, wasn't it? Because you need to have that low resistance ohm meter. Yeah. All right, mate. Right, I've got I've gone through my list. Anything else you wanted to cover today?
Well, fault currents, I think, is a good one for me this week.
Fault currents.
We tend to think of fault currents at the end of the circuit or at the current. So when you basically look at the end of the circuit, you don't really go, I could have a lot of fault here. So I have an installation where maybe a transformer is in the next room, and you have to be careful the other way. Short cables actually equal more current. So by having shorter cables or bigger conductors, you're actually increasing your fault current because of the amount coming in and the challenges that it has. And then basically how do you calculate the different fault levels from single phase, 2-phase, 3-phase, you know, and the differences between them, and then the impedances of the transformer windings.
Right, well that's where I was about to go to. I mean, you need obviously significant data about transformer impedances. This is kind of touching into arc flash calculation territory there, mate. Which could be something that we do on the next podcast. Actually, we can look a little bit preview of that. But yeah, let's think. Yeah, how long are we in on here? Yeah, we're about 50 minutes in. I think what we need to do is, why don't we on the next one or the one after? Let's. You've got Mike Frayn's book, right? You've got it.
Yep.
Arc Flash. So maybe we can talk a little bit about Arc Flash, and we can then come back to your short circuit, because that's one of the consequences of significantly high fault currents. You know, bear in mind, you know, with Arc Flash, we're talking about magnitude of current, but we're also about magnitude of time, because the intensity of the energy could be a very small amount of current, but for a long period of time, or it could be a huge amount of current for a short period of time. But it's about the energy that's there, and we'll talk briefly about transformer impedances and fault currents when we look at that. I think because I think that would be that's, you know, Arc Flash is one of those areas that I've always mentioned it on, even on the 2391 and stuff. I always cover Arc Flash because I think that it's something that every electrician is exposed to. If they do a ZE test or a PFC test, they're exposed to Arc Flash. So yeah, I think we'll cover Arc Flash as a little subject to discuss on the next one. But that's good, mate. That's good. Anything else?
No, Space. No, that's me.
Let's wrap it up. Okay. Well, we are later in the day. This is a midweek catch up, really, an after work midweek catch up. So we'll conclude. We're just about 50 moments in. Next one, we will look at a little bit of an introduction to Arc Flash and so if it's relevant to electricians, how it is or is not relevant to electricians. More of a discussion than anything else. And I will see if I can find out more information about this net current. I'll have to dig this thing out. Because it's really annoying me. I can't find it. And got the 2391 next week, so I'll probably have some testing on my head. So I might come up with some testing challenges or testing. One word I try to avoid is myths. Because everywhere I look online, people are trying to break myths, falsify myths, and like debunk the myths. And I'm like, hang on, let's just, you know, let's calm that down. But I'll see if we can come up with some challenges with testing. One of the fun things I like to talk about is the significance of the inspection over the testing and how we really manage that. And you know, that's one of the hardest things to manage. So I think that's one of the things that we'll focus in the next one as well. It's good discussion points. And anything else that comes our way. It's 2 more days this week, so who knows what will happen. We may have some significant news in the next couple of days. All right, mate. I will sign off. Anything else for you to say?
No, I'm very good, thank you, and
all right,
thanks for listening.
All right, catch you everybody later. We will be back, next week for the next one. Bye.